Good morning, good afternoon, everyone. Welcome to the third installment of CharIN virtual conference. Today we have an exciting program for you, but before we start, I would like to encourage you to watch a few videos we prepared for our past events. Enjoy, and we will start shortly.
DECRA is the sponsor of this CharIN festival. We are expecting a bigger number of electric vehicles available for the consumers to buy. The CharIN festival is really about giving e-mobility an opportunity to grow.
What we've been doing here the first few days was building a CCTS test event. With that we try to get, the problem gone for here at these test events. We try to charge vehicles and chargers in the field. We hope to do with the CCTS device to get, this synchronized and have one way of charging, one way of checking if the vehicle and the chargers are compatible with each other.
General topic is what we've also heard today in this conference is HPCCV, so the high power charging for commercial vehicles. We plan to have also again a test event in Europe next year in the fall time. So that's not announced yet, but we will announce that latest in May next year with the test event in North America.
Yes, we decided within CharIN to make at least 3 events per year. So our idea is to have one in each region, in each key region, one in Asia, one in the US, in North America, and one in Europe. So we announced yesterday already that we have our second CharIN festival at Lucid facilities in Newark, California next year.
Hello, everyone. We're here at the third CharIN North America conference. I'm proud to be the host of this event as a spokesperson for CharIN Alliance. And this event is particularly important to all of us because it's combined with a testing symposium, the place where we test interoperability of multiple cars, multiple chargers produced by many vendors. That type of interoperability is what allows consumers to have easily deployable, easily chargeable products. And that type of ease what makes a compelling buy. That's what eliminates the fear, where do I charge, how do I charge? It makes it simple. Today, we heard from many panelists, from many speakers, that type of ease of use and ease of deployment is exactly what creates scalable market. And collaboration with multiple stakeholders responsible for many aspects and many links of this value chain is what will drive the innovation, what will create the market of economy of scale and enable us to enjoy products that price competitively and at the same time deliver us a wide array of very valuable features. Enjoy this event, be a part of it, enjoy the conversation, and remember, combined charging system is about simplicity. It delivers AC and DC charging without you thinking about it. Just plug and charge.
Here at the CharIN event, talking business, talking policy, talking protocols, everything to help the e-mobility sector moving forward, lowering the barriers. Check out CharIN and come to the next one. We look forward to seeing you.
I hope you enjoyed our videos. And now I think it's time for us to start our program. So today we have the third installment of our conference. Next slide, please. I would like to bring your attention to some of the housekeeping rules that we would like all of you to go by, but I think if you have attended 2 previous events, you're already quite familiar with that. So we can move to the next slide, please. And today we have a very interesting conversation. Today's conversation, we will have focused on V2G or actually V2X applications of combined charging system and ISO AC 15118. Well, once again, my name is Oleg Logvinov. I am CEO of IATECA, a startup here in New Jersey and California, and I also serve on the North American CharIN board. And it is my pleasure to welcome all of you to the third installment of our event. Next slide, please. So first of all, I would like to introduce what happened during the previous days of our event. Well, as you may recall, on the first day, thanks to Erica from SIPA, we learned that actually we have a very large shark pursuing the humanity to watch out for. It's a climate change. And of course, electrification of our transportation is something that can change how we're affecting our environment and what we do to the environment we live in and what we're going to live through and what will be left to our children and our grandchildren. So electrification of the transportation is a hugely impactful force that can create decarbonization of our environment and reduce the pollution. And pollution is one of the major causes of death in humanity. So making our life cleaner and greener will also help to extend not only the life of our world, but also to make environment better for our children and grandchildren. We had a great panel on day 2, moderated by Bart from Subject, and the focus of the panel was on plug-in charge. As you can see, our esteemed panelists talked about the benefits of plug-in charge to multiple constituencies, how plug-in charge can help us to create opportunities for business. It's not just a technology. It's a technology that enables seamless and simple and secure, most importantly, secure interactions between the vehicle and the charger, and allow us to create new businesses and new business models based on this platform. That was an incredible panel, and huge thank you to Bart, Mike, Mufi, Chris, and Cliff. excellent job and really great insights that were shared during this conference and during the panel. And I'm sure that you will be very much enjoying listening to the recording of the conference when it becomes available online later this week. Next slide, please. So during today's event, you will see how we can actually work together to create V2X applications. We will start with a small introduction from our moderator, Noel Christosimus from California Energy Commission, and then we'll proceed with a demo from Lucid and Ade, and that will be followed by a panel discussion. And today I actually play two roles. I'm your host, but I'm also a panelist on the panel. And we'll finish, of course, with a Q&A. And I hope you will prepare a lot of questions. I would like to ask you, welcome to ask your questions during the event through the chat, or save them for the end of presentations. And then we'll have a great discussion. We'll allocate ample amount of time for Q&A session, and I hope you will enjoy our interactive discussion. Next slide, please. Next slide is actually quite interesting. It's an introduction of all of our panelists. Well, we kind of missed one slide with the picture, but that's okay. So I would like to hand it off, Noel, to you for a second to introduce yourself and your panelists. One thing that I would like to ask you to do, though, is when you talk about yourself, it would be great if you could spend maybe 1 or 2 sentences talking about what brought you to clean transportation, what brought you to decarbonization, what brought you to electrification of transportation. What is your personal story in connection with that? So Noel, with that, I would like to ask you to introduce yourself and also provide an opportunity for your panelists to self-introduce themselves.
Hi, everyone. My name is Noel Chrysostomo. I'm an air pollution specialist working in the Fuels and Transportation Division at the California Energy Commission. As an introduction to myself and why I work in the things that I do, I studied Earth and energy systems in college and have worked in the utilities, nonprofit, and government sectors for the past decade. And I thought that policy was one of the most effective ways for me to contribute in the fight against climate change and for clean air. And the work is personal, as I had asthma as a child, and I'm always a little bit surprised and taken aback when I travel to a place with poor air quality and my symptoms return. So that motivates what I do for the state. Let's go through the panelists in the order that they're shown here, left to right, starting with Eric.
Hello. Yeah, my name is Eric Bach. I'm the Vice President for Hardware Engineering here at Lucid Motors in the Bay Area. We're a startup and focused, of course, on electrification, first and foremost by compelling products. How did I get into the sector? I've been working in the sector for about 8 years now. I entered it by joining Tesla Motors in 2012. What motivated that? I was working prior to that at a really large German auto OEM in the north of Germany in basically the planning departments. I had a good outlook of the products of the next 10 years, and I was planning vehicles to come in the next 10 years. And the CO2 targets, the 95 grams per kilometer, were essentially the trigger for me thinking about how can we make this transportation cleaner, and electrification and Tesla upcoming with the electric cars actually made me wonder whether there's a better way. And then thinking about that, the efficiency of the electric powertrain, the localized energy generation, but not coming out of the tailpipe, that was very enticing to me. And also just the electric motor being a more efficient converter and a very quiet one as such. All these benefits made me wonder whether I shouldn't be in this field. I joined Tesla and ever since have caught the EV bug.
Well, I guess I'll continue. My name is Oleg Logvinov, and as I said, I'm a CEO of Ade. What brought me here? Actually, believe it or not, I started my career as a power engineer. I was designing large-scale power grids, delivering megawatts of power across the country. And after that, I became a telecommunication guy because I realized that everything in the grid is about communication and the ability to control large-scale system. Evolved into becoming communications engineer and working on Internet of Things applications. And during my career at ST Microelectronics, it became very apparent to me that electric vehicles represent an opportunity of essentially ginormous Internet of Things hubs on wheels. Not only batteries, but it's an IoT hub with ton of information streamed together. And guess what? Managing IoT and applying IoT to decarbonization seemed like a very natural progression. And that's how I became a part of electric vehicle charging infrastructure development company.
Thanks, Oleg. Joseph?
Yes, hello. Joseph Gottlieb, CTO and founder of Rhombus Energy Solutions. Basically, I got into electrification by my father. He was actually a battery specialist in the Navy. And I was in Florida once, and there was a small company that was making electric Fiats. They were taking a gas Fiat Spider and converting it to electric with lead acid. And so I thought that was pretty neat. And so that stayed in the back of my head. I went through engineering programs and got a master's in electrical engineering. Started off in semiconductor and then slowly branched off into my own businesses, including converting cars from gas to electric a long time ago, before lithium was very popular. And so it was kind of an exciting venture. I was the president of the Electric Vehicle Association of San Diego for 10 years. And then got into batteries and battery management systems. And finally, with Rhombus, the last 8 years, we've been focused in on charging and charging infrastructure, building high-powered electric vehicle chargers. And so that's been my passion. Again, it's really been about the technology and having a kind of a greener planet to live on for my children as well.
Thanks, Joseph. John?
Hi, I'm John Halliwell. I'm a senior technical executive working with the Electric Power Research Institute. I'm based in Knoxville, Tennessee. I've been with EPRI about 13 years. Prior to that, my background is in electrical engineering as instrumentation and controls engineer. Had spent a lot of years at Oak Ridge National Lab. Came to EPRI really interested in advancing power electronics and efficiency of LED lighting and product efficiency. About a year into my stay at EPRI, the opportunity came up to move into the electric transportation group, and I've been there since 2008 and active in standards for the EVs. I actually have an EV now in our family that we drive, and I guess I'm on board now as far as EVs. I really see the advantages, and have a grandson. I want to hand off a good world to him, so that's why I'm here.
Thank you, John. And last but not least, William.
Thank you very much, Noel. Hi, everybody. My name is William P. Martinez, Global Product Manager from ABB. So how do I get into this world? I used to live for about 6 years in Norway, where I was actually working in oil and gas. But everywhere you look there, it was a bit of an interesting setting, because you see a large population of EVs continuously growing, and that really caught my attention. So 6 years into living in Norway, I was like, okay, so what is this? Because this is growing very fast and it's very interesting. So looking into it, finishing my projects, suddenly out of nowhere, an opportunity opened in the south of Europe to develop a charging network for Tesla. So somebody happened to have sent a tweet to Elon Musk. That's how he behaves. From the Portugal Tesla owners group, a team was assembled, and in a matter of months, I was given the opportunity to be part of a team that built the charging network from Lisbon all the way to the south of Italy, and we accomplished this in about 3 years. So once I understood how charging networks are deployed, the next natural move to me was to see where I can use this knowledge, and now, instead of building charging networks, building the technology that will enable spreading infrastructure throughout the world. Next, I joined the House of Charging, ABB, where now I'm responsible for the product management for this webbox. So this has been my journey to the EV world.
The amazing power of Twitter. Thank you all for sharing your stories. Let's go to the next slide. So we have a, like here's your image that you're referencing. I'll let you provide that story.
Thank you, Noel. So before I hand it off to you for your presentation, I would like to share something very special. The reason we asked Noel to be a moderator of today's panel is not just because we like him, we do, but there is also a very important reason for that as well. Last year, when we had our member meeting in Oakland, California, we invited Noel and his colleagues to participate with us and hold a roundtable, an open exchange to brainstorm how can we create an environment where policymakers, technology developers, consumers, users of this technology can actually work together side by side. Typically, what you see in the market is policy as a reaction to the technological changes or technological changes as a reaction to change in policy. And the advice that one side gives to the other almost never exists. How can we change that? How can we change this paradigm to create a collaborative effort where policies and technologies can be developed in parallel and at least be informed by each other? That was the subject of our brainstorming. And at the time, it seemed like a far-fetched idea that may never have a materialization in the future. Well, I'm very proud to say, and Noel, a huge thank you goes to you because you were the driving force behind the implementation of this idea into practice. What you will see in Noel's presentation is something that I would consider to be probably the first in the country, an opportunity to demonstrate that policy development and funding of the development work can happen at the same time. What you will see in Noel's presentation is a very important step forward for all of us. It is a participation of policymakers in the development of the technology. And Noel, I will not say anything more, but I wanted to preface your presentation with a huge thank you to you being a driving force, being a visionary in the space, and really helping to transform what we were kicking around back at our member meeting as an idea into actually reality. So thank you, and with that, the screen is all yours.
Thanks, Oleg, and thanks, panelists. So one of the things that I appreciated from all of our stories was moving toward the end goal of cleaning our air, reducing environmental impacts on the climate, and leaving the planet a better place for our families and our communities. And so the goal of cleaning the air and having our vehicles run on clean energy really motivates the work of the California Energy Commission. And on the next slide, spans the entire range of our efforts in charging infrastructure. On the next slide, the work starts at the statewide level, where we work with other state agencies to analyze infrastructure needed to, previous slide, I apologize, needed to catalyze and underpin the vehicles that are necessary to clean the air and achieve our climate change goals. And we work on reducing the barriers to electrification, ranging from creating policies and programs and other investments in technology, all the way down to collaborating with local governments to improve processes on installations to ultimately ensure that there's sufficient charging for all Californians. In a few slides, I'll discuss findings from our analysis about how smart charging can reduce the strain on the power system. And as this figure suggests, facilitating scalable technology really forms the basis of our partnerships with industry. And one of the key goals of the Energy Commission's programs has been to plant seeds that grow into opportunities for the competitive private market to sustain itself. And in the next slide, I'll give an example of that, continuing Oleg's story. Clean Transportation Program has long had a history of supporting efforts for consistent, reliable, and scalable infrastructure for zero-emission vehicles. In 2015, the Energy Commission invested in industry efforts to create procedures and equipment to test compliance with hydrogen refueling standards and to verify that chargers are accurately dispensing the electricity that they report to drivers during charging sessions. And a more recent example that was mentioned on day one by Commissioner Patty Monahan and Rustam Kocher a leader of CharIN's Heavy Vehicle Charging Task Force, is the Energy Commission's support of the National Renewable Energy Lab's evaluation of high-power charging solutions for commercial vehicles. On the next slide. The Energy Commission has often played the role of facilitator and convener to help innovators and researchers prove advanced technologies so that they can help us meet our environmental goals. And we think that our investment with the US Department of Energy and with CharIN for the high power connector will be critical to assist manufacturers develop a commonly usable infrastructure for vehicles that connect with the edge of the grid, which is the theme for today's panel. These chargers are being designed to draw or even give back more than a megawatt of power. And although they're not here yet, the HPCCV is an acute example of the need to coordinate our preparations of the grid, charging systems, and vehicles so that we can accelerate our transition to clean energy. So the goals for my slides is to set the context for grid challenges, technology basics, and applications for V2G. And from that, we'll have a demonstration from Lucid and Ioteca and presentations from infrastructure providers Rhombus and ABB, and utility perspectives from EPRI. So on the next slide, transportation accounts for 50% of our footprint in California, and decarbonizing it will be one of our biggest challenges to achieve neutrality in carbon by 2045. State law requires that by this time, California's electricity sold to retail customers will be 100% powered with clean energy. One of the greatest challenges to this will be addressing the need for seasonal storage, as the max amount of generation from photovoltaics occurs during the spring, while max demand from consumers occurs during the summer. Black and Veatch studied the implementation of this law, Senate Bill 100, and identified that in a few decades during the fall, state could have generation shortfalls in the evening when demand remains high, but the solar has set. And they estimated that 30,000 gigawatt hours of storage might be needed to close these gaps. But they also considered what if instead of building stationary storage, they overbuilt renewables and used the additional load from EVs to address curtailment. Ultimately, Black and Veatch found that the incremental system cost of achieving the goal could be reduced by $60 billion by deploying smart charging as a substitute for stationary storage. And while I couldn't share those slides pictured here, I captured a recently published analysis in collaboration with UC Berkeley of the renewable integration benefits from managing EV charging in the next decade, with a grid powered 50% or more with renewables. Depending on the generator mix, with solar primarily on the left, and a more balanced mix with solar and wind on the right, we show the true power of not just adding EVs, but managing them intelligently. We could nearly eliminate curtailment with smart charging of EVs. And in the next slide, clearly smart charging in vehicle to grid could help answer the call to simultaneously and cost effectively decarbonize the power system and the transportation sector simultaneously. So practically speaking, how do we intelligently get an EV's energy into the power system? Let's go through an example system diagram, starting with the grid manager's needs in this top left. A utility operator could request that more or less load occur at a particular point on the grid, represented by the stationary EVSE or charger if it's DC. This could be implemented via direct request to the charger or an upstream device like a building energy management system, or perhaps an entity like a service provider aggregating many vehicles and chargers. These communications could be implemented using a variety of protocols, with a few common ones listed here, as long as the utility's request is able to be specified in the local context of the connection, so that capacity can be safely managed. Given that the vehicle is physically connected with a local mains via the charger, there are opportunities to leverage embedded metering technologies and controls to verify and actuate performance. The key is encouraging flexibility in the control architecture while ensuring that automakers can maintain a consistent interface that scales across utilities, EV service providers, automakers, and locations so that customers have convenience in their charging experience. Overall, the key priority is for us to get customers the energy that they need as cleanly and cheaply as possible. And if they can charge for less or even get paid for grid services, that's even better. So in the next slide, I'll display how industry is rapidly building upon this basic design to create products that can fundamentally change the way that we think about transportation and energy infrastructure. In March, Volkswagen has stated that in about 2025 to 2030, its fleet of EVs will grow, tripling its energy storage capability to 1 terawatt hour. More than 80% of the car and driver readers of the story were surveyed and agreed that getting paid for vehicle-to-grid services would make them more interested in a VW electric vehicle. Furthermore, commercial fleets like UPS are interested in vehicle-to-grid, not only to support the grid, but enhance the resiliency of their facilities. And in April, working with Oak Ridge National Lab, in lieu of a plug, they demonstrated that a 20 kilowatt wireless charger with an 11-inch gap would maintain 92% charging efficiency. But wait, because there's more. Vehicle-to-grid opens the door to peer-to-peer charging services. Last year, Rivian stated that its trucks and SUVs will be able to charge each other. And with a University of Florida's researchers' vision to utilize automation connection devices like those featured last week to charge vehicles in motion, this could have a dramatic savings on the amount of stops that vehicles would need to fast charge and reduce the amount of weight that is carried around in our vehicles in the form of batteries. This will improve efficiency and save raw materials that are impacting our environment. Ultimately, these use cases that not only affect energy flexibility could also democratize charging infrastructure itself, which is what gets me excited and optimistic that we can solve the climate crisis. So with that, I'd like to hand off the presentation to Eric at Lucid and Oleg Vyatecha to present a global premiere of their collaboration on making these technologies a reality and a mobile energy resource. Eric?
Thank you. Thanks, Noel, for this great introduction and highlighting the benefits of our V2G capabilities once we can actually tap out on them. And there's a lot that has to be done to make this all happen. And it's going to be a path that we have to go. It's not going to happen overnight. And we'll see in these discussions what are the stepping stones to get there. One of those stepping stones we want to present, Oleg from IoTecha, myself, using this virtual demo that we've put together. And let's go next slide. So Lucid and IoTecha came together because we both believe in the power of V2X. And we said we need to show everybody what we can actually achieve by using this interesting technology and the huge energy storage devices that we are driving around in our long-range EVs nowadays. Next page. So we are joined up at the hip to number one, show you the virtual demo today. It's basically demonstrating the cost savings achievable with a V2X use case using a Lucid Air and an IoTecha charger in our building facility, in our Lucid headquarters. We are demonstrating peak shaving, peak shifting, and time of use rate benefits and optimization. And this is basically a precursor to the in-person meeting that right now we're still planning to hold in November of this year at our Lucid facilities, where we'll actually show it in action, the V2G and how it works, V2X. Next page. So again, who is Lucid? We're not the most known electric vehicle startup, but we are gaining traction. We've based all our work on developing great technology. That's the foundation of everything. If you've got great technology, good things can happen. So we're a Silicon Valley tech startup, roughly 1,000 employees right now, mainly working from home nowadays, but making great progress in delivering our first vehicle, the Lucid Air, which is going to be this beautiful luxury EV that you see here. It's got more than 400 miles of real-world range according to EPA 5 cycle. We'll show that and demonstrate that. And it comes with abundant power also, so more than 1,000 horsepower, come basically for free if you've got a big battery pack inside a car. Next page. So as a demonstration vehicle, we are using the Lucid Air, the car that's going to be available for sale beginning of next year. It's got a, let's say, an average battery size of around 100 kilowatt hours. It's got an onboard charging system that can charge AC and DC, and the AC portion goes up to 19.2 kilowatt, which tallies quite nicely with what Noel brought as a reference point, so around 20 kilowatt. Charge and discharge. So it's AC and DC bidirectional capable already from the get-go, all built in. The onboard charger supports ISO IEC 15118. It's connected via the CCS combo connector. So everything we're driving for in CharIN is implemented in this vehicle, and it's going to be available for sale in 2021 early. Next page, please. This is the world reveal of our onboard charger. You're the first to see this piece of tech that's buried deep inside our vehicle. It's a very, very capable device, all developed in-house, as is our entire powertrain. As said, it's bidirectional, 20 kilowatt. Europe is a little bit higher due to the three-phase nature there. It does up to 350 kilowatt DC into the vehicle. We also have built in a boost converter, utilizing every single component multiple times via an intelligent switching mode. And that allows us to hook up the vehicle to the existing 400 volt infrastructure, because our battery pack goes up to 924 volts, which is pretty much the highest voltage of any battery pack out there. And if we plug that into the existing infrastructure at 400 volts, we can't charge the pack. So we've built in the boost converter. That basically makes charging easier, less painful. And of course, as said, it supports the ISO 15118 communications protocol, and it's over-the-air updatable. As we roll out more functionality on the ISO 15118, we can add functions to this charging system. Next page, please. So again, just a highlight on the specs. AC charging power 19.2 kilowatt in the US, bidirectional. DC charging power over 300. Basically right now 350 kilowatt is available on the CCS standard. As just mentioned, the DC charging power at a 400 volt range up to 60 kilowatt. That covers 100% of the available 400 volt infrastructure nowadays. Bidirectionality for both AC and DC. It's got integrated components. It's not just the onboard charger. It's also our high voltage distribution box all captured in there. It's got all the switches to make all the functions work. It's got a 400 volt DC-DC converter inside to convert the 924 volts of battery voltage into a 400 volts intermediate bus for using current components that are available at a mass market price. And we don't have to develop a 924 volt capable components. So we built that into this box. And yeah, it also has 10 kilowatts in that function. So we can support our AC system and the heater and the compressor in that with 10 kilowatt power, which is quite powerful. All of that packaged in only 17.8 liters. Next page. The demo we are going to run you through in November is going to be at our headquarters. This is our 305,000 square foot facility in the heart of Silicon Valley. It's in Newark, very, very convenient to get there. It houses our engineering center. It also houses our prototype manufacturing center where we build all of our prototypes right now. It also houses the first flagship showroom where we can do customer interactions, learn about how to be efficient in our sales channels. The electrical properties of this building, we are being supplied by Pacific Gas and Electric, as so many in the Bay Area. We've got a commercial electricity rate schedule, the E19P, for people who know what that means. And we have roughly 1 megawatt peak demand, and I'm going to show a little bit more in the next slide on that. First of all, we're going to show a brief video of the location where we're going to hold the charging event in November and how that is used right now during this phase. These times our prototypes are grounded. We'll be able to jump back into them very soon, I hope. I'm already very itchy. As you can see, it's quite stunning to see so many beta prototypes, as these cars are, ready to be taken out for range evaluations, charging testing, etc., etc. And that facility that you saw where they are parked, all that is exactly where we're going to have all the EVCs, all the test vehicles late this year. That's why I wanted to share that with you. With that, I want to hand over to Oleg.
Thank you, Eric. It was an impressive video, and I look forward to test driving one, when the opportunity presents itself. It's enough sitting at home. We need to get on the road, right? So a little bit about IATECA. First of all, we're very excited to do this demo together with Lucid because really an opportunity to provide V2X charging is, in my opinion, it's a paradigm shift in what we do today with infrastructure. It positions the electric vehicle in a totally different light and creates additional services opportunities and also business opportunities based on that. So a few words about IATECA, where we came from. IATECA is also a technology startup. You probably don't know us as a brand because we provide technology components for those who build chargers and vehicles powered by combined charging system and ISO AC 15118. We started, well, close to 20 years ago as a startup developing power line communications that is today used as a backbone of communication between the car and the charger. From that, we became part of ST Microelectronics, built silicon, implementing that communication, and in 2015, it became very apparent to us that the future is electric, and electrification requires a lot of help from developers like ourselves to make this magic that actually allows vehicle and the charger talk to each other and talk to the grid to be very simple. This magic has to be implemented with complex technology, but very simple when it faces consumers, and consumers like simplicity, right? Simplicity is a key. If something is too complex, remember the blinking VCR syndrome, it's not used. So we decided to help our customers to implement chargers and vehicles in no time and support them, which is very important, with a high uptime, high reliability through cloud services. Next slide, please. And for that, we actually developed a whole portfolio of products that today we provide to our customers. We call it our IoT-owned platform. Remember, I mentioned that IoT is a key in decarbonization. We truly believe that. And IoT is our DNA, and it's a part of our name, IATECA. It's a prescription for IoT. So today, we provide modules that go into the car. We provide modules that enable a complete AC or DC charger. We provide edge aggregation platforms, our cloud, and our cloud is already pre-integrated with Object Root CA ecosystem. So we actually left pretty much no hurdles to be overcome for our customers, just plug and play. And the last but not least is a very unique piece of technology that we have today as a product. It's our sniffer. It's basically a device that allows you to passively monitor ISO 15118 communication between the car and the charger. No man in the middle, no interference. You just see communication between the car and the charger, and you can decode it. We call it our IoT-owned platform, as I mentioned before. Next slide, please. So we're very proud to take this platform and transform it into the products. You can actually find our modules in quite a few AC and DC chargers sold around the world. But this charger is something that we're very proud of. It's powered by Ateca. It will be introduced this summer by our partner ECS, a company located in California. And by the way, I forgot to mention that Ateca is also a startup based in California and New Jersey, so we're bi-coastal. And this charger is probably the first 19.2 kilowatt ATM device coming to US market with 15.11.8, fully enabled, capable of bidirectional charging, and all of the other very interesting features that you can find at that type of device. So we decided to take this device and use it for the implementations that we're going to demonstrate together with Eric today. Next slide, please. So what are the benefits of V2G, V2X? If you think about the architecture of premises, whether it's your home or office building or hotel or parking garage of apartment building, or even a city street, we can probably find conglomeration of cars, right? We'll have multiple cars connected to this infrastructure. It could be as few as 2 or as many as thousands, right? Depending on where you are, what setting you're in. You will probably have some type of green power connected to it, whether it would be solar or wind or some other form of renewable energy available locally. It probably will be connected to the same cluster. We may have a storage attached to the same cluster. And of course, we'll have a feed from the grid. How do we manage all of that? How do we manage it all together so it provides us with the best possible implementation that creates value to all of those constituencies? Well, once again, intelligence of IoT comes to help. And that's what we're basing our estimation, how we can generate value going forward, providing V2X services, is power of the information. Information flow among all of the stakeholders here is the main enablement that we can use here and leverage here. Why ISO 15118 is important? Very simple. We need a secure platform. Security is a key. If we're talking about exchanging monetary information, or we're talking about payments, or we're talking about energy flows, all of that is mission critical. And mission critical information flows must be secured and must be protected to the highest possible degree. And that's what 15118 was designed for. And that's why today it is a choice of our implementation. So if you look at benefits to consumers and employees, well, wouldn't it be nice to be able to charge your car at the lowest price without even thinking about it? Of course. Would it be nice to earn money while you're charging your car? Absolutely. It's great. And that opportunity presents itself at work. An opportunity for fleet operators? Well, OpEx reduction is a key, right? When we're running a fleet, optimizing the energy use, optimizing the cost that we use to charge our vehicles is very important, because at the end of the day, that affects directly profitability of our operations. Smart charging allows us to see state of charge. We understand not only what we're giving to the vehicle, but what also the vehicle expects to get from us, combines that with route planning, combines that with intelligent planning of assets and distribution of assets, and even V2X, V2V transfer. All of a sudden, now we have an opportunity to optimize how we're putting the energy into the vehicles, taking the energy out of the vehicles, distributing or sharing the energy among the vehicles. And at the end of the day, that is a great way to save some money. Of course, V1X and V2X services. V1X, it's a passive, basically managed charging. V2X, it's basically where the vehicle is able to give energy back. If you think about an opportunity that is estimated to be just in the US alone in about 7 years, McKinsey is predicting that that market by itself, managed energy services for vehicle charging, to be about $15 billion a year. It's an enormous opportunity. And fleet operators will be great players here. And by the way, if you look at employers, they're kind of becoming fleet operators too, because if you have a fleet of vehicles parked at your facility, you can get all of the benefits we just discussed. So that plus, you can provide additional value to your employees, because your employees can actually participate in those services and make money or save money, depending on what program you're implementing. The business can become greener. So it's an image, it's a sustainability question. We can also offset energy costs that employer is paying for the energy feeding into the building. Eric just shared what their facility, Lucid facility, is consuming. It's a big number, and savings of even 10, 20% of that amount will amount to a very substantial addition to the bottom line. Energy companies, well, it's not a secret. If you look at today's world, you see that traditional oil and gas companies are now getting into the business of electric vehicle charging. Why? Because electricity is becoming a very important fuel today. In fact, if you look at the report released this morning, actually, energy distributed to the vehicles now is becoming something that is close to 10% of energy that was used for transportation in Europe. That's a significant milestone. So I encourage you to look at this report. It's very, very telling. And of course, that creates opportunities for energy companies to become participants and players in energy markets, providing V1X and V2X services. Well, and last but not least, automotive OEMs. Opportunity to change the total cost of ownership of your vehicle because you're now providing energy services as a component to save money or even earn money. It's a game changer. It's really something that changes how you perceive what the vehicle price is, what the cost of the vehicle is. The total cost of ownership combined sale price plus operations price plus energy price, and now you can add the component of savings or earning. Well, it is a huge, huge, huge difference between electric vehicle and ICE. And of course, as a consumer, that's what I'm looking for. I'm looking for that type of value. Next slide, please. So combine it all together, and all of a sudden, V2X is becoming something that I think will drive adoption of electric vehicles probably more than anything else. And back to you, Eric.
Yeah, thanks, Oleg. Right. So you saw all these opportunities, how we can all win from the application of V2X, right? It's the drive of the car, total cost of ownership, it's the cost of energy, it's the grid usage, it's the grid balance, it's the investment into the generation, etc. So humongous benefits. And here we are showing a couple of those. We've picked out a driver, a Lucid employee, John. He's 40 years old. He lives in Oakland and commutes to New York to our headquarters every day. It's a 20-mile one-way commute, so he drives 40 miles a day, which basically takes about 10% of the energy of his car because we've got 400 miles of range. And at home, he has the ability to charge for 17 cents per kilowatt hour. He's signed a contract with us, and he is giving us as his employer the permission to use his vehicle for V2X services in the range of his battery SOC between 40 and 90%, in exchange for receiving free energy and electricity from us that covers his commute. So there's a mutual benefit right there. His request is that he leaves the facility at least with 50% of SOC by the end of the day, because that's 10% he'll use on his daily commute back and home for the next day. In addition to that, we are offering a financial incentive for making his asset essentially available to us. Next page. And with that, we look at the different opportunities that we as an employer can take here. On the top left, you can see the rate schedule of our facility. This is E19P. And we see at peak, we pay 16 cents per kilowatt hour. And off peak, it's 11. Partial peak, it's 11. And off peak, it's 8 cents per kilowatt hour. So there's a 100% increase during the core peak hours. And then on the right, you see roughly the day-to-day max peak. So we had, for instance, in September last year, a max peak of 95 kilowatt. Typically, it's a little bit lower. During the day, it fluctuates from off peak between 500 kilowatt to 950 kilowatt. So there's quite a lift there. And also important to know is that our peak happens during the peak hours also. Now, if you look at the lower left, what does this mean in terms of cost? We do pay a $17 per kilowatt hour maximum demand charge. And then if our maximum demand happens during the maximum peak hours, we pay $19.26 on top of that. So every kilowatt we use during the peak hours, we have to pay $36 per kilowatt, which is quite a lot of money. In the part peak, that goes down to $22 essentially per kilowatt. And then, energy cost comes on top of that. So it's a double payment schedule, power and energy. So we are trying to offset both in this example. Let's go to the next page and see what that looks like. All right.
So how does it look like? Well, as we mentioned before, if you look at what's behind the scenes, it's a pretty complex ecosystem of multiple stakeholders, multiple elements that need to play together in order to enable that type of experience. The goal here is to optimize the energy used behind the meter. In other words, we're not feeding any energy into the grid. So devices that are participating in this collaboration, obviously vehicles themselves, chargers, they have to communicate with a local energy management system or edge aggregation component in this case. And of course, clouds that basically sets up all of the policies and making sure that all of that works together harmoniously. So in this demo, what you will see is basically what an operator would see from a console connected to the cloud and displaying the operation of the charger and the vehicle interaction with the charger, interaction among the charger. In this example, we'll have just one vehicle, but imagine that you have thousands of them connected to the same grid. So artificially, we set the example to have a vehicle load kind of similar to the load of the building. Otherwise, the charts will be off the scale. But in reality, when you look at the buildings that is capable of consuming a megawatt of power and being connected to the same meter as all of the chargers, you can see that the opportunity presents itself to feed essentially energy from hundreds, if not thousands of vehicles into the same grid. And basically, in order to make all of that work, we need to have ISO 15118 communication between the charger and the car. We need to have the ability of the chargers to communicate with the local aggregation points that provide real-time management of the energy consumption or discharging in this case. And of course, we need to understand the information coming from the meter, metering the energy flowing into this property. So at no time we exceed the energy production versus the energies that we're consuming by the building or by the facility from the grid. So all of this complex interaction amounts to the fact that from a user's point of view, you just plug and you charge, and you do pretty much nothing. And remember what we talked about plug and charge. It creates a very interesting platform for us to integrate vehicle into the fabric of the street, building, facility in this case. And having that, we actually don't need to burden our drivers with thinking about where they connect, what fabs they use. They just plug and the system recognizes them. The cloud recognizes them as a participant of this ecosystem. Their preferences, such as an example, leaving with 50% of the tank still full, is already accounted for. And the system will optimize energy discharging and energy charging so in such ways that the demands and desires of the driver will be met. So all of this complex interaction is effectively invisible. So what we decided to do, we decided to create a scenario that is basically almost like a time-lapse video of what you would see on the screen of the cloud console and how it will help you to essentially understand what is happening behind the scenes during this process. And with that, welcome to enjoy the video.
This example illustrates the charging process in reverse power flow enabled by CCS ISO IEC 15118 V2G and implemented in the Lucid Air and ECS AC charger powered by Ioteca. This demonstration is based off the actual electricity cost at Lucid Motors headquarters in Newark, California. On the screen, you can see the pricing table with off-peak, partial peak, and peak time intervals with the associated costs per kilowatt hour. The AC EVSE and the rest of the loads in this demo are connected to the same power source. This setup is reflected in the center of the topology screen. To see the real-time energy flows, we are now switching to the monitor screen. Let's say the car arrived at the Lucid facility at 8:30 a.m. It's partial off-peak time and the car is able to charge. You can see the energy flowing from the grid to the car and the rest of the loads in the building. You can also see the pie chart depicting real-time energy split. It is showing only one color. All energy is coming only from the grid. The car's battery starts charging and is charging until it reaches 90% around 11:30 a.m. Peak time starts at noon. It is an opportunity for the car to sell the energy back into the microgrid of the facility. You can see the energy flow in yellow, going back from the car into the microgrid. You can see the real-time energy split. It is now showing two colors. Energy is coming from both the grid and the car. The battery is discharging until it reaches the lower limit of 40%. On the right side of the screen, you can see how much money can be saved per year. It is a very significant number. And after 6 p.m., partial peak time, the car is charging again, up to 50% for example, until it leaves the parking lot at 6:30 p.m. On this screen, we can see the real-time load for this charger that includes periods of charging, discharging or reverse power flow, and then charging again. The ability to charge and discharge can generate significant value for both employee and employer without any additional effort.
Yeah, that is how it works. And there is significant savings for all of us. And so we believe that V2X, the capability of V2X is a real game changer in TCO of EVs, and essentially one of the big topics that we should all strive for in the electrification. Our demo between IoTeca and Lucid has shown that we can enable employers to intelligently use the peak shaving and time of use shifting by using their employees' assets in their parking lot. They're sitting there, they've been invested. Let's make some use out of it. And we've seen that just by using this 50% storage capacity in the battery of those assets and cycling through that in a not very crazy use cycle, we can save $5,000 per year. And that's a real number from our headquarters. Clearly, every company has a different usage profile, but this is just one example. So I think we've demonstrated the benefits that can be shared between the employer and the employee. And on top of that, the employee can also benefit from the capability of V2G at home, at his residence. Now taking this 50% charged car back home, plugging it into his house at the end of the day in the still peak time at his house, and then at night charging it again at the lowest possible rate, and doing that over and over again every single day. And then of course what we're talking about here in context is the entire grid usage, scaling this ability to every single vehicle, every single residence, every single building for the betterment of mankind. Thank you. Next page. And now there's only one thing left to do, right? In order to tap out on this crazy potential, you just need to reserve your Lucid Air. Thank you.
Well, thank you, Eric. Thank you all. It was our pleasure to share this demo with you, and I really hope that all of us can become beneficiaries of V2X services that ISO 15118 with CCS can provide to us. Thank you very much. Eric, thank you for this great collaboration.
Thanks, Oleg. It was a pleasure.
Thank you, Oleg and Eric. It's pretty exciting that the Air is going to have this functionality built in. There are already some questions that we'll get to in the discussion, but that means the clock is ticking for the industry to resolve these technical and electricity questions and customer business questions that our next three speakers are going to dive into with with Joseph leading off. Joseph from Rhombus, please take it away.
Yes, very good. All right, so as I mentioned before, Joseph Gottlieb, founder and CTO of Rhombus Energy. What we've got in our first slide here is, Rhombus has been building electric vehicle chargers now for quite some time. We build a 60 kilowatt, a 120 kilowatt, 125 kilowatt, and a 500 kilowatt, excuse me. And they are all V2G capable. They're certified, the 60 kilowatt is certified, going through certification, finishing certification the end of this month for 1741 SA and HECO and Rule 21. So we have been placing together components to build containerized systems as a concept to be able to drop into certain locations as kind of a power hub for mixing renewables, battery systems, external gen sets, and utility to be able to support the number of vehicles out there that is kind of rapidly growing. So we mainly focus on bus and truck industry and industrial vehicles, although we do have consumer vehicles as well. And so as you can see from the diagram, this is an AC power hub where there's an AC network that gets distributed, which is kind of the standard thinking of when you've got a facility and you're running a bunch of chargers, you run AC to each charger, and then that charger could either be AC to DC, kind of a standard high-powered charger, or the AC could be used for onboard charging through one of the platforms like Oleg just showed from their company. So that's one particular configuration. The next slide shows a DC power hub configuration where we use a high voltage DC network which requires a little less on the conversion side and a little more efficiency and less costly converters for building that high voltage DC network that gets distributed around then to wherever the location for these vehicles are. And then the vehicle charging themselves is a DC to DC style charger, either external or internal. And again, being able to combine everything onto the DC bus makes the energy mixing a little bit easier as well in terms of the PV going into the battery system onto the DC bus. It's much more efficient to keep it as DC and allows you a little bit more flexibility in those capabilities as well. So on my next slide, I kind of discuss some of the interesting issues that we have. We've deployed a lot of PCSs out there, and being in the bidirectional space, we've also done a tremendous amount of energy storage products and projects. And so what we've found is very quickly, there's a lot of information coming into what we call the power converter PCS system that can change its performance and can change how much power it can pull or how much power it can push. The nice thing is, as you can see at the bottom, at least I only have a few things that I have to control. It's power into the unit, power out to the unit, and power factor on the grid side. So that's makes life a little bit easy there. But you have to listen to, for example, if the utility gives you a demand energy response and the grid is sagging, then you've got kind of a dichotomy of, well, who do you have to listen to? You're supposed to be providing your VAR support based on UL 1741 standards. And on the other side, you're supposed to be providing the utility power, but you can't provide them the power they requested because you're giving it in VARs, not in real power. So on this slide, I like to kind of go through and explain to people the difference between saving money and making money in these different types of programs. So there's an on-grid, just like Lucid had shown, where you're not exporting to the grid. It's a great way to save money, but it doesn't necessarily make you money in this particular case, but it will save a tremendous amount of money. And how that gets shared between the user and between the main company, that's kind of some of the good questions. And so you've got, matching the meter, squashing peaks, time of charge type utilities. Now on the making money side, you've got, the grid and utilities that actually will pay for certain services for those energy storage products to be there. So example, you can listen to the utility and you can get paid for whatever they're asking you for. They'll give you a time of day number and you can say, hey, we need this much power tomorrow and we'll pay you this for it, yes or no. And you come in and you participate, you say, yes, I can provide that, and you get paid for that. They also have carbon credit programs, which get a little bit more tricky. But again, that's a way to kind of get paid, because then you can sell essentially those carbon credits. And then I also like to mention off-grid, because people want to know about the emergency services pieces. And so in that particular case, you're not really listening to anyone. You're only providing the voltage required to support whatever load is connected, and you have no idea what it is. It can turn on and off lights. There's an emergency operations center that's running communications. So you don't listen to anyone except providing power to those outputs. And then on the next slide, it gets a little more complicated, but again, some of the solutions that we'd like to talk about are the standards that have to accept and incorporate a way to move grid interactive inverter to different locations. Big, long, complicated thing. However, when you sign up to a grid interconnection, it's just for that point at the grid where that location is and that particular grid interconnection. So if you have a piece of equipment now that can move somewhere else, wherever it plugs in, it has to have an interconnection agreement and understand what the utility wants. So when you're plugged into like port A, let's say, you've got some requirements by the grid that say, hey, I need a power factor of 0.8. But when you move across town to this connection point, it's 0.7. So you have to have a way of the utility to be able to convey those messages and the charger to convey those messages down into the vehicle that actually is the charger, if it's an onboard charger, to be able to keep those commands up and operating. Utilities should all speak the same language. This is a huge problem that we've seen across the board. Right now, it's very utility dependent. And so you get all sorts of different utilities that want DNP3, they want OpenADR, some want Mosquito, and so all different types of connections make it very difficult. The protocols also need to be fast enough for whatever request. If it's a day ahead request, it can be pretty slow, but if it's load matching, it needs to be relatively fast. We think that currently, like the 15118 seems to be handling things very well. How do you deal with dropouts and lost links? If you lose the communications to the back-end system and a vehicle plugs in, what's it supposed to do? Is it supposed to give power? Is it supposed to take power? So you have to have those all kind of lined up and understand what they're supposed to be. I also talk a little bit about the fair participation from the utilities, because what happens is if you're signed up to a dollar program and the utility's paying you, they make a request, you accept that request. If you don't deliver that request, there's a penalty over here. So if you make this, say tomorrow, I'm gonna have this much energy available, but you know what? The guys who own those cars, they all decided to take off at lunchtime and have a long liquid lunch and they're not coming back. You're losing that energy. So how do you deal with those type of things fairly so that the utility doesn't penalize you? Because the vehicles may or may not always be available at the times that they want them. Finally, manufacturers costed rate sheets. So how much does that electricity cost the consumer? I buy a vehicle for $50,000. How much is that battery pack worth when I go and I cycle it? So if I use it for exporting power, how much am I actually paying out of that full price of that car? Because eventually I'm going to have to replace the battery at some point. So how does that play? The vehicle manufacturers really should be the ones that can specify that. And they should have a way of specifying that so I can determine, or a company can determine, whether or not it makes sense to use that vehicle's energy. And then finally, some of the clearinghouse transactions and how that's all going to work. How am I going to get paid for my vehicle to be used at these locations? In the Lucid model, it's very simple. You get free electricity, and you get the charge that you need when you need it. In other cases, if I'm just at home, how does that transact? How do I actually get paid for the kilowatt that goes out of my system? And how does that all kind of come together? And so that actually is a pretty good use for some of the blockchain systems, but that all needs to get figured out in the future there. So I think, is that my last slide? I believe that is my last slide. Yes. So thank you for your time and listening to that. It's very confusing. I understand that. But again, these are the things that we have to pilot through going forward.
Thank you, Joseph. Those were a great summary of some of the key enduring questions in the industry, and we are receiving some chats that we'll get to after our final two presenters. But this is going to make for a great discussion, and we'll have now William from ABB to discuss their approach to solving some of these questions and how they will sell a new product that will have to address those technical challenges and business challenges with a brief presentation. William, go ahead.
Thanks, Noel. So basically, I'll be doing an introduction of what are the market drivers for a DC wallbox. So basically, the question is why we need a DC bidirectional wallbox charging segment in the V2G picture. So I'll start by saying that there is a misconception or a cultural shock related to charging when you transition from an ICE, internal combustion engine, to an EV. I say this because we're used to having to stop every once in a while at a gas station for 5 minutes to fill up and we're good to go. Well, at ABB, the home of charging, we believe that by providing convenient charging solutions for every occasion, we ease the transition from having to stop those 5 minutes to fill up to never having to stop again to refuel or charging. What I mean by never having to stop again? Well, basically what I'm trying to say is that because in order to achieve our vision to a zero emission reality, we need to enable the possibility for your vehicle to charge while you do the things you like, hence why 90% of the time you don't have to stop to charge as most people do now. But once you park your car at your residence, at your office, I mean, you name it, there's a charger ready. There's a charger ready for you. So I mean, there's a charger ready for you to naturally plug in and charge wherever it is. And if it's not required, well, you can or should be able to charge at least at home. So said this, we identified that the DC V2G wallbox to be a key charging solution to meet the needs everywhere where you can park your vehicle between 1 to 6 hours. So what are we looking at ABB that makes the DC wallbox a must-have? So first, it needs to be compact. It needs to be something that is easy to install, typically between 1 or 2 people max. It needs to be simple, plug-and-play solution with over-the-air updates to always stay relevant. And it's very key and important that it's a future-proof solution that meets the current vehicle voltage demands and also future EVs. Obviously versatile, which can be transported in as an MCS, a wall box can be installed on the walls or pedestal mounted, for example. A key and very important point is the costs. We need to be looking at something that is price competitive. So when developing this technology, we're looking for a cheap solution compared to a DC fast charger, that the installation itself should be cheap as limited changes are required for existing electrical infrastructure. Yes, if we compare to typically AC charging solutions currently, it might be on the higher end. Nevertheless, with a V2G DC wallbox, we open a whole new world of business models, which we have basically discussed in the previous presentations, where the owners of the chargers can literally make revenues over time or save money while allowing you to access of their battery. Next slide, please. Sorry, one more point on the previous slide. So talking about the onboard converter, so we take two approaches. So we see luxury and vehicles like the Lucid, which show this amazing onboard converter capability, where you can enable V2G from the get-go. And you also have cars that are not on the luxury end, where we see that the OBC or onboard converter has reduced power, maybe around the 7.5 kilowatt output. So with a V2G DC wallbox and in such a compact shape, you can basically skip the onboard converter and deliver the full power to the battery. Next slide. So here, so it's a bit of a recap of what we said. So what are some of the DC wallbox V2G opportunities and challenges we've seen so far? So if you were in the last CharIN in the Netherlands, ABB showed our first prototype that took about 2 years of development. So now we have put together a new interface to ABB's bidirectional wallbox that we're aiming to reflect the high quality standard, performance, clean design that we're characterized for. The technology behind this DC wallbox, DC bidirectional wallbox, is pretty much backed up by ABB's 130 years of heritage of accessible technology leadership for safe, smart, sustainable electrification. We have over 12 years of direct experience in the solar business, and the knowledge we gather that we constantly have by deploying shared networks with partners currently in over 80 countries around the globe. So as a recap of what we said, so what are some of the opportunities we see at ABB based on this discussion? So we see that fleet owners will have the capability to make significant revenues by enabling EVs battery storage at a given time during the day and being able, for example, we see projects currently prototyping FCR, so frequency response needs, as an example. We see homeowners in that segment wanting to store their energy from solar panels in their EVs for traveling or in case of a power backup whenever necessary. OEMs in the same situation, they have the possibility to play a very significant role in this new ecosystem and much more so. There are plenty of challenges, and you can see in the bottom right of the screen. The charger is placed in the center of a communication between OEMs, vehicles, digital services for aggregation, EV infrastructure providers, and power generation. Among all these players, we have standards, communication responses, grids to follow. So here at ABB, that's what we're trying to do. We're compiling this, prototyping, putting it together, and end of this year, starting 2021, it will start deploying officially for commercial. At the moment, we're sort of say testing the technology and deploying our B2G knowledge. So it is useful, and we can put some of these opportunities and business models into play. Thank you.
Thanks, William. It's exciting to hear about these new ABB chargers and Lucid Airs planning to come across the world and hopefully to the United States as well to offer vehicle-to-grid solutions. And we look forward to answering some of the questions that came up during your panel as well, your presentation as well. But we'll close out first with John from EPRI, who will be discussing how utilities are going to prepare for this wave of vehicle-to-grid technologies and accommodate them into their systems. John, go ahead.
All right, thank you, Noel. So I'm going to jump in here with a discussion more, not so much about the technology, but what goes beyond the technology in terms of utility interaction. So we're trying to integrate these vehicles into the grid in a way that, at the end of the day, benefits everyone if it's done at the low-cost method, the way that accommodates the grid in the best way possible. This is a graphic of the United States and Canada showing, I counted roughly 34 utilities that have programs. About $3 billion have been announced or in process of being proposed for demonstrations, educational programs, deployment of infrastructure. About 2/3 of this money is actually being spent in California. You can look at the numbers there on the left side between PG&E, Southern California Edison, SDG&E. There's a significant amount of money there, more than $1.5 billion in California. So why is the utility industry doing this? Well, first of all, understand, while there are 34 utilities on this map, that means this is about 1% of the utilities in North America represented, over 3,000. Now, if you look at the population of the U.S. and where utilities fall, about, I think it's between 100 and 200 utilities serve about 80% of the population. So if you had, the 100, 200 largest utilities, you have a significant number of people sort of covered at that point. So how do we get to scale when we integrate vehicles when you have so many different utilities? I know Eric mentioned utility rates. The business case for his employee was based on that utility rate. Well, that rate is unique to that utility and may be different in the utility in the adjacent county or a different community. The employee might find that it's worthwhile if they live in one community and not in another. And that's a real challenge when you think about consumers and the fact that vehicles are much more mobile than other loads that utilities have served in the past. I think the key here is that utilities are working on pilots and programs that are, they're dipping their toe in the water, looking at infrastructure, understanding how it interacts with their systems. A lot of the conversation today has talked about customers managing their energy use and optimizing energy at their facilities. Oftentimes when they do that, it's actually beneficial to the utility. They're flattening their load out. They're looking more like a steady load without a large peak, which is beneficial to the utility. But then utilities have to think about, feeder loading and broad area distribution of energy and how power capacity is managed at the utility level. So all those things come into play as well as utilities look at the adoption of EVs and the challenges that come from that. Optimization is, I think, one of the probably the note of the day that we've all talked about is optimizing, and generally that optimization results in the lowest cost. And I think that's really important to keep in mind, that we're really managing power and energy to try and keep the delivery of the fuel cost to a manageable level. You can go to the next slide. As these pilots and field trials are underway, it sort of begs the question. One more slide forward. There you go. So how do we get to scale? What are some of the key factors that are going to help us go from smaller pilots or a few vehicles here or there to just having this be something that can be done by consumers across the U.S., across Canada, worldwide? I think keeping things simple, a streamlined workflow. Some of the diagrams show that there are multiple players. There's a lot of interactions. I think it was William had mentioned, or no, Joseph mentioned that there's the different players in the chains, and sort of figuring out how all that connects together can get very complicated. So that streamlined workflow, and that involves things like what standards are going to be used, and what protocols, and what technologies and communication paths. Lowest cost. So again, not just for energy provision, but when you think about automation, the more intermediaries you have in a control system, each of those represent cost. And so having the fewest steps between, having the endpoints have intelligence with very little in between is probably the optimal situation. At the end of the day, vehicle grid integration has to be competitive with other alternatives if it wants to be a player. So if stationary batteries can provide, peak shaving and energy, power consumption and sourcing more at a better cost point than vehicles will struggle to compete in that area. So you again have to focus on that lowest cost. Reliable utilities, I think it was Joseph, you mentioned penalties. If the utility wants you to do something and then you don't deliver, there's generally something on the downside for you as well, because they need that reliability. They have to count on what's being provided. One way to accomplish that is to look at existing channels that utilities have where they deliver information today. And that also ties back with lowest cost. If utilities have already invested money in demand response systems and automation, leveraging what's out there is also, a valuable way to approach this. Scalability, that if only a handful of vehicles have the capability, if only a handful of chargers have this capability, if only a handful of utilities are doing this, it's going to be really challenging to get to scale. We need, vehicles that can do this, ubiquitous charging stations. That's a challenge, is getting this hardware and having that sort of ecosystem, having lots of endpoints so that it has a scale. And it's been mentioned several times about cybersecurity. I think that's kind of a given in the utility industry, that anything we're deploying in the field, it has to be secure. We don't want to put at risk our electricity system, for things like managed charging. You can go to the next slide. So when you look at this, what are some of the hurdles? And I was trying to think through, what are some of the things I've seen? I've been involved in this since 2008. We actually published J2847 Part 1 as SAE standard for utility control of vehicles. And I look back, that was published in June of 2010. To my knowledge, that has only been used on vehicles and pilots. There are no production vehicles using J2847 Part 1. That was based on use of IEEE 2030.5, the Smart Energy Profile. That's been out there, a decade. So it's not about the fact that standards don't exist that we haven't seen this, go mainstream. So I don't think any one standard is going to make this happen. I think it comes back to things like a market. I live in Tennessee. I can't sell a kilowatt hour or a kilowatt to my utility. I can't sell capacity or energy. Until that market is available and ubiquitous, it's a challenge. California is certainly moving forward in a lot of ways. They are investing money. Is California a large enough market to drive the whole country? I don't know. if you really don't get this to happen at other utilities in other parts of the country, I think it's a challenge. So that national market for sale of capacity or energy is important. And again, that's sort of outside the technology realm. It gets into regulatory and a lot of other factors. Are consumers ready for this? I think it's been mentioned, multiple times about consumers. I think Oleg mentioned that, their focus was to keep things simple for the consumer. If this is a hassle, you might get somebody like me who likes to poke buttons to take on, the duty of managing my car, but you're not going to get the general consumer to do that. If it isn't automated, if it isn't simple, they're not going to play. People are going to be concerned. Will it impact my ability to drive? Will it hurt my car? Will it leave me stranded? What's in it for me? I think consumers are going to be thinking about, okay, this probably is wearing my car out a little faster than, what am I getting in compensation for that? So that whole value proposition needs to be figured out. And again, against that backdrop of utilities that have different rates, I think Joseph, you mentioned interconnect agreements. That's been a challenge even in pilots in California that I've seen, that getting interconnect sign-offs, that utilities aren't used to things that move around, that deliver energy to the grid. So that's a challenge we're working through. And I think, William, you mentioned low-cost solutions. Again, I think for consumers, this equipment can't be expensive or they're not going to invest in it. So they're thinking, that whole calculus of what am I going to get in return for investing in this? And again, lastly, having a broad set of utilities on a national scale, I think we need that. OEMs don't build cars for one state. They build them for not just the US, they build them for North America, they build them for a world market. So they're really looking for that broad set of utilities so that there's enough scale that it makes sense to incorporate capabilities in vehicles and charge manufacturers. So it's important to them to see a big enough market to put the intelligence in their systems. So I'll close out there. That I think those are some of the hurdles that we'll have to address as we go forward that sort of fall beyond the technology realm. So thank you, Noel.
Thanks, John. This is a great way to start off our discussion among everyone, and we can, before getting to that, have everyone participate a little bit. I know there have been many chats, but first we want to get a sense of who's in the room with some poll questions that will help us understand what you do, if you drive an EV, and a new question related to vehicles grid.
Yeah, as you can see, please use the pop-up window for answering the question and not the chat window. So we have the analysis right away. And yeah, I'm just curious if we have the same demographics as on the second panel. So last time we had around 50% working in the automotive industry and 25% in charging network infrastructure and hardware. So let's see if you have some diversification in here. So hitting 60% already, we see 38% working in the automotive industry, also 38% in charging network infrastructure and hardware, 11% government and university, actually 0% utility, and 14% software and technology. So some slightly changes due to the panel 2. Let's continue with the second question about the demographics, just your office department. And in the second panel, we had around 70% working in the field of technology, R&D, and engineering. So let's see. I can see the same trend as in the second panel, but just let's wait for a few more seconds. Okay, answer 60% already answered the question. We have 60% of the audience works in the technology, R&D, and engineering field. 3% sales, actually 3% marketing this time. Last time it was 0%, so an increase in here. 22% in the business development field and 12% policy and government. Okay, thanks for answering this question. And the final question is related to the overall topic of panel 3. Would the V2G option increase your interest in buying an EV?
Thanks, Ricardo. And to remind the audience, this was the question that was posed in the Car and Driver article reporting about VW's plans to incorporate V2G into their next generation of EVs. And for comparison, they had an estimate of 81% of their readers responding that they would be more interested.
So then they made a really good estimation, at least on our basis here on our survey, because here we have 75% of the audience would their interest would increase in buying an EV if the V2G option would be there. So pretty similar to the other survey.
Great. Thank you, Ricardo.
You're welcome.
And if we could restart our cameras for the panelists and go to the next slide, we'll be able to delve into some questions and answers from